Yeah, actually, I want to show you some video first before we continue. Okay, because today our topic is on resistor. However, I want you to take a look at the connection of the ammeter and the voltmeter first. Okay, so watch this video. Then maybe we will be doing more Kahoot games. All right. Actually, I have a request from the weekend class, They asked to do more Kahoot games related to the topic they are learning. How about all of you? Would you all like that? Yeah? Can, right? But I mean, we adjust accordingly lah. Sometimes when, we are too tired, lesson a bit too dry, then we go into Kahoot. Okay, otherwise we have to focus on the open-ended also. Hi, Harini. Okay, now let's watch the video. This is about the connection of ammeter and voltmeter. Okay, just a very short video to show you how or what will happen if you connect it wrongly. I mean, I talked about it the last lesson, right? But you didn't see what will happen. So just to let you see how the needle actually moves. If you connect it wrongly, it will go to negative value. What you need to do, switch the wire. Okay, switch the wire from the positive to the negative terminal. All right, and then the other one as well. Okay, and as mentioned by the actor, I think it's a teacher in the video, he said that it doesn't matter red wire, green wire, or black wire. Doesn't matter so long as you are connecting it correctly from the positive to the positive terminals. Okay, then negative to the negative, it will work. Okay, so another thing you need to learn is about the variable resistor. All right, so variable resistor, let me open the video. How to connect variable resistor, all right, to the other components in the circuit. So take a look here. Another name for variable resistor is the rheostat. Okay, rheostat. And it's quite huge. So you take a look at how this is being connected. Okay, so if you take a look again, it says that if you are connecting this way, what happens is you look at the light bulb, it is very, very bright. Why is that so? Because now the current is flowing through, okay, this part, you see? Okay, the battery is here, made up of two dry cells. So the current will then flow through this wire, through this thick, fat metal rod, without going through the resistance wire. So the current flows through the thick metal rod, goes back into the wire, okay, and then flows through the battery again. Okay, so this is a very simple connection without going through the resistance wire. Can you see that? Okay, and then the next part, he was saying that if you are going to put it here, okay, so what happened is the bulb will never light up. Why? Because now look at the current flow, okay, from the battery to the wire, okay, and then it has to go into this whole coil of the resistance wire. There are many, many, many turns. That means okay, the current must flow through the entire thing, which is very, very, very tedious. That's why it is not going to light up. So after flowing through the whole thing, right, no more electrons left to actually light up the bulb really, okay, because the resistance is too high. However, if you connect it this way, okay, you see, you change it, right? He connected this like that. Okay, so what is happening here? Even though the bulb doesn't light up, does it mean that no current is flowing? Okay, actually there's current flow. So the current will flow through the wire, okay, goes through this metal rod, okay, which then, if you look at the physical item, the variable resistor, okay, you will see that, the metal here is connected to the resistance wire. Okay, so it flows from this metal rod, all right, through the connector, touches the resistance wire, and then it goes round and round and round and round and round and round, and then come out from here and goes back to the battery. Can you see? So after that, he did something, right? He moved the tap. So he moved the tap.
Large section of the coil. But if the tap is set over here, the currents will have to.
So the bulb lights up, isn't it? Why is that so? Because right now, current flows out of the battery through the wire and then reaches the metal rod, then goes down to the connector and goes into the resistance wire. Now there are lesser coils, right, for the current to pass through. So lesser resistance, that's why you have enough of the electrical energy to light up the light bulb. Clear about this? So far, okay? Zenith, okay now? Yeah? So you know how the current flows? Can, okay. So the moment the tap is moved towards the right, I have more coils ready, right? So more resistance. More resistance, then the light bulb will be very dim. So let's try again. We go back to this part. Okay, can you see that? Remember I talked about the dimmer last week? So if let's say you have dimmer, the lightings are at home that has got this dimmer function. How come we can adjust the lighting to be very, very dim, so romantic? Then after that, we can adjust it to very, very bright also because of the rheostat. This variable resistor allows us to do that. And then, you know, the traditional type of radio, the big one, right, you carry around. How come you can adjust the volume to very loud and then to very soft? Same thing, we are using the variable resistor. So if you decrease the resistance, okay, there'll be more current flowing through, light bulb will be brighter. If it's the radio, the sound will be louder. Can you understand this part? So if I make the resistance very high, little current can flow through, right? Then the light will be very dim, the sound will be very soft. Understand better now? So this is how this thing works, okay? But if you connect it wrongly, then of course the whole thing won't work. Either it's always very bright or it's always not going to be lit. Okay.
You could have chosen to use the other end of the coil instead. Just make sure you have the other end connected to the tap. All right, easy, right? Bye-bye.
Okay, so this is how the variable resistor works. I can send you the video if you want to, okay? Yeah, so later maybe I send it and see whether, let me check the size of it. It's useful because you can actually view it. I try to send, see whether it can send through. If cannot, then we'll try another way. So confirm everybody finished the exam, right? Feeling good about it? No. Okay, share with me. What's your score like? Haresh is like, no.
I got C5.
How come? What are the
I
topics?
didn't use the keywords. It was about chapter 10.
Chapter 10 is what?
Like absorbers and then radiators and then emitters and all that stuff.
Heat. Okay. Okay. Yeah. You can see the video.
And then the water with the ice cube in the water and then the gauge. It was not convection, it was conduction.
You mixed up. I see. But at least you learn something lah. Then year end, when you have the assessment again, you won't make the same mistake. Okay, so you can see in the chat, right? I have already shared with you, okay, how to connect the rheostat. So that way you can watch it again on your own, okay? And then perhaps remind yourself, this is how it works, because this topic belongs to next semester. We all know, right? Okay, now, so let's look at our worksheet. Not too tough, actually, right? if you look at my screen, okay, I have all your responses here. Okay, so I will be looking. So far, I think question 1, no issue. Okay, so I open up individual ones. One person got it wrong. Okay, just one person for question 1. Okay, so take a look. How do you connect the ammeter and the voltmeter? Right, if you are talking about connection inside a circuit, okay, ammeter is always connected in series. Okay, ammeter is always connected in series. So that means this should be my ammeter. Whereas the voltmeter is always connected in parallel across a component. So the connection is here and here. All right, and this voltmeter will tell me what is the potential difference. Later, you are going to see in other questions. That's why answer is B. Okay, and how do you connect the ammeter? If you are asked, let's say this is an open-ended question. They will ask you, okay, how do you connect the ammeter to the battery? Or how do you connect the ammeter in this circuit such that you can get a correct reading? Make sure, because this is the negative terminal, right? And this is positive. Here should be negative, here should be positive. Okay, any question? We saw the video just now. All right. And this one should be positive. This should be negative. Do you know why this is positive and why this is negative? Imagine this is the wire, just one piece of wire connected to the battery. Can you see that? Okay, just now the first video I showed you, right? Positive to positive. Yeah, so that's how you check. Question 2. Okay, you have a long story, conductor obeys Ohm's law, it's an ohmic conductor. Ohm's law states that provided physical conditions such as temperature remain constant, the ratio V over I remains constant when V or I is varied. What is this ratio V over I? Okay, what is this ratio V over I? What are we trying to find when we take voltage divided by current? If you recall the triangle formula, yeah?
I confuse I with ohms.
Sorry, I is ohms. Which one?
I confuse I with ohms.
I see. Okay, right. This is current. Always write down to remind yourself until you are so good at it, then you no longer have to write it down. Okay, R is for resistance. So the unit for current is ampere, capital A. This is V, volts, and this is ohm, omega sign. Okay, so copy this down somewhere if you cannot remember. Therefore, answer is C. R equals to V over I. Question 3. When a charge is moved between 2 points in an electric field, work is done. Okay, the formula for potential difference is given by potential difference equals to, so this is the formula, right? Work done over charge. Which of the following is the definition of potential difference? Tough, right? Yeah, I know it's tough. Usually never asked in Sec 2, but that's okay. So work done, we know that work done is actually, related to energy. Why? Unit is joules, so it's energy. I saw some of you chose this, but unit current. Okay, then you have to start thinking, what is the meaning of current? What is the definition of current? Yeah, so in this case, it's energy per unit charge. No change over here. Okay. it's not going to be